All right, so this is kind of a continuation of a previous video on elimination method for solving system of equations. In the previous question, we looked at one that was probably a bit more suited for solving by substitution. You already have y all by itself. You could have substituted negative x plus 3 back into equation 1, and that would have allowed you to solve for x. So when we look at a few different equations here, a few different systems of equations, some of these may not be so friendly to use with substitution. So when using the elimination method, what we're trying to do is get the coefficient in front of either the two x terms to be the same absolute value, I would call it, or the same magnitude, and then we can add or subtract them to eliminate the x terms, or we can do it with y. So I'm going to try and show you 3 examples here, but I'm not going to solve the systems the whole way. I will just get you one of the numbers, and then the solutions are down here that you could finish off the question to get the other one. So for the first example here, this one has a couple options. The first thing that jumps out to me is that 4 is double 2. So the coefficient in front of the x term is double the coefficient in front of the first one. So in this case, our lowest common multiple between 2 and 4 is 4. So what we could do is take equation 1 and we could multiply it by minus 2. So if I do equation 1 times minus 2, I would get negative 4x. If I'm multiplying it by a negative, this is going to turn to be positive, and that would be doubled again, so it's 8y. And then we have to do it to the other side as well, so 7 times minus 2 is going to get me minus 14. Then what I can do is I can add the second equation with my new first equation, and that will allow me to eliminate the x terms. So if I write in equation 2 right underneath it, so equation 2 is 4x plus y equals 5. Now because these are opposite, the negative 4 and the positive 4 are opposite, I'm able to add them to eliminate them. If they were the same number, you could subtract them. So when I add these together, negative 4x and positive 4x make 0. So we've eliminated the x terms. I have now 8y and 8y plus y makes 9y, and I have negative 14 plus 5, which gets me negative 9. So finishing off this part, I have 9y equals minus 9. Divide both sides by 9, and I have that y is equal to minus 1. So that would be the first part of your solution, and if you were to continue by taking that value and substituting it back into one of the original 2 equations, you would find that your x value would end up having to be 3/2. So if we look at another example, so in this one there are no pairs of coefficients that are as easy as the last example, because 5 is not a multiple of 3 and 6 is not a multiple of 4. So what we're going to have to think is, what would my lowest common multiple be? And we can pick and choose. I would probably go with x in this case, but we can do the y's just because we did x last time. So if I look at the 4 and the 6, so if I think about 4 and 6, what's my lowest common multiple? So I'm thinking about the times table for 4, so 4 times 1, 4 times 2, 4 times 3, 4 times 4, and I think we already have one here. So 12 shows up in both the 4 and the 6 times table, so it is the lowest common multiple. So what I'm going to do is I'm going to actually have to take equation 1 and multiply it by something, and multiply equation 2 by something else. So I'm going to try and get both the coefficients of y's to be 12, and this time I think I'll just leave the sign the same, so I'll get them both to be negative 12. So I'm going to take equation 1, and in order to get 4, or in this case negative 4 to be minus 12, I'm going to multiply the whole thing by 3. So I'm going to do equation 1, and I'm going to multiply it by 3. That would give me 3 times 3x, which is 9x. 3 times minus 4 is going to give me minus 12, and then y, and then 3 sevens are 21. Now that equation that we just made there, that is the exact same line as equation 1. If you were to graph that, it would give you the exact same graph. So we haven't changed what it's worth because we multiplied both sides of our equation by the same thing. So now what I'm going to do is take equation 2, and I'm going to get this to be minus 12 as well. So I'm going to double everything here. I'm going to multiply it all by 2. So 2 times 5x is 10x, 2 times minus 6y is minus 12y, and then 2 times 8 is 16. So in this case, I've intentionally made it so that both equations have terms in it that are actually the exact same. So a lot of times people think about getting them the opposite so they can add them, but it is okay if you just subtract them. So if I was to do 9x take away 10x, that would give me minus 1x. If I do minus 12y take away negative 12y, it's the same as doing minus 12y plus 12y, which gets me that 0. So I have eliminated the y term, and I'm still subtracting, so it's 21 take away 16, which gets me positive 5. So I have minus x equals 5, which means that x must be negative 5 if I, say, divide both sides by minus 1. So having x equals 5 as the first part of our solution, and we can go down and confirm that because I have the full solution below. So minus 5, if you were to substitute that x value back into your equations up top, you'll get that the y value has to be negative 11 halves. So we'll do one more. So I see that the 7, the positive 7 here and the negative 2, they're already opposite signs. So if I were to get them both to be 14 and then leave this one negative, then we could just add them. You could do something with 6x here, and you could subtract them, or you could make it positive 6x and negative 6x. As long as you're multiplying or dividing every single term in each equation by the same number, then you're going to get another equation that is the exact same line that you can use. So in this case, what I'm going to do is I'm going to take equation 1 and I'm going to multiply it by 2. So what does that give us? We get 4x plus 14y, and that's going to equal 2 times 24, which is 48. For equation 2, I'm going to get this to be negative 14, so I'm going to multiply it by positive 7. Now where does that come from? The lowest common multiple between 2 and 7 is 14, so that's the number that I can get both terms to be by multiplying. So I'm doing 7, so 7 threes are 21, so that's 21x minus 14x, if I multiply this term by 7, or sorry, y, I think I said x. And then finally I have to multiply this by 7, so it's going to get me minus 28. So now the terms have the same absolute value or the same magnitude, and they are opposites. So what we can do is we can add them together. And when we do that, we get 4x plus 21x gets us 25x, and the y's cancel out, we get a 0. And over here, we're going to get just 20. So we have 25x equals 20, and if we divide both sides by 25, we will get our x value. So 20 divided by 25 would simplify down to 4/5. We divide both the top and the bottom by 5. So we think that the answer for our x value is going to be positive 4/5. If we go down and check, that's true. So if we substitute back in our original equations, the 4/5 for x, we should be able to solve for y and get 16/5. So there are 3 examples of how you can use elimination to get one of your values of your solution, of your coordinate, where those 2 lines would cross, and then if you have your textbook, the Pearson one, you can try some questions on page 437, 356, and 7.